Hello, today we're going to be changing fractions to decimals. And this first part up here, we want to think about how we say it. So we're thinking about place value. So for instance, if I said 0.4, the correct way it would be said as 4/10 because 4 is in the tenths place. And you're like, 4/10. Well, as a fraction, I would write that as 4/10. 4 out of 10. And then I could simplify that to 2/5 or 2 out of 5. So let's try a couple examples. I have 0.48 or 48 hundredths. That 8 is in the hundredths place. So you go by the last digit, what place value is that in? So I have 48 hundredths. Now they're both even numbers, so I could divide them both by 2. But if I want to go for the greatest common factor, so that I don't have to divide more than once, I find that I can divide by 4, which gives me 12/25 as my final answer. So that means that 48 hundredths is the same thing as the fraction 12/25. Same amount, just written two different ways. This one right here is 73 over 100, and I cannot reduce that, 73 being a prime number. So these two are equivalent to each other. My next one, I have 125 thousandths because the 5 is in the thousandths place. So tenths, hundredths, thousandths. That's what that TH on the end. Now I look at this and I know anytime I see a 25 and a bunch of zeros, I think of it as money. So like $1.25 and $10. And then I know I can at least divide by 25 or a quarter. So I think to myself, how many quarters are in $1.25? Well, there's 5 of those. And then in $1, there's 4 quarters. So in $10, there would be 40 quarters. Now when I do that, I find that I'm like, oh, 5 and 40, I can also divide by 5, which gets me down to 1/8. Now what that tells me is I could have divided both of those numbers by 125 to get to my final answer in one step, but I always know when I have big numbers like that that the quarter's going to work. So that means that 125 thousandths is equivalent to the fraction 1/8. Moving down here, I've got 6, and it's in the tenths place. Sorry, the focus keeps going in and out there. And I know I can divide those both by 2 because they're even numbers. And so I get 3/5. So that means 6/10 is equivalent to 3/5. This next one is kind of hard to see there. I don't know if I can zoom in any closer. 1.3 or 1 3/10. So it's 1 is the whole number. And the decimal point separates the whole number from the partial number, or the fraction or decimal in that case. So 1 3/10. So 1 3/10 is my answer there. And I can't reduce 3/10, so I'm done. My last one like this, I have 3 64 hundredths. So I'm going to write that as 3 64 hundredths. And I look at that and right away I'm like, even numbers, I know I can at least divide by 2. But I also find that I can divide by 4. So I'm going to end up with 3 16/25. So 3 16/25 is the same as 3 64 hundredths. Remember, you can pause this at any time and try some out so that you can try doing them on your own. Our next one down here, we're going to be converting from a fraction to a decimal. And when we do that, we're going to put the top number, the numerator, on the inside of our house. The bottom number, the denominator, gets locked outside the house. Now, normally when I do this, I can put something into that first digit. I can go, I can get that many out of that. At this time, I can't. So since I cannot make a group of 5 if I only have 4, I'm going to add a decimal place and a 0, and a decimal place and a 0. So now I'm not asking can 5 go into 4 because it can't do that, but can 5 go into 40? So out of 40, how many groups of 5 can I make? Well, I can make 8 groups. And then 8 times 5 is 40. When I subtract, I get 0, so I'm all done. So that means the fraction 4/5 is equivalent to 8/10. My next one here is 1/8. So remember the 1 is going to go inside the house because it's the numerator. The 8 is going to go on the outside because it's the denominator. So once again, I'm like, can't do that. If I have 1, I can't make a group of 8. So I'm going to go ahead and add those zeros and decimals in there. Can 8 go into 10? So if I have 10, can I make a group of 8? And I can make one group. And I subtract, and I get 2. So since I have something left over, I'm going to add another 0 and bring it down. So now how many times does 8 go into 20? 8 can go into 22 times, because that'll only give me 16. When I subtract, I see again that I still have something left over. So I add another 0. And I bring it down, and I say, how many times can 8 go into 40? Well, that's 5 times. And now I'm done. I've gotten a 0 down here, so that means that 1/8 is equivalent to 125 thousandths, which we also found up top going the other way, if you remember. My next fraction is 3/10. Now, because it has that tenths, if I am thinking about place value, I'm all done right there. It is 3/10. If I do the division, you can see, like 10 can't go into 3, but it can go into 30. So if you don't intuitively get it with place value, you can do it that way. Now these are all what we call terminating decimals, because when I got to the end, I ended with a 0. I was able to come to a terminating or stopping place. This next fraction, when I turn it into a decimal, we're going to find that that never happens. I never get to that 0 there. And in fact, a lot of times when this happens, you're going to see a pattern emerge. So I'm going to say to myself, well, 3 can't go into 1, but 3 can go into 10. 3 times. And then I'm like, oh, look, I have something left over, so I add another 0 and I bring it down. And then I go, oh, how many times can 3 go into 10? It's the same question I just asked myself. So when that happens, I'm just going to keep getting that same pattern. It doesn't matter how many times I do it. This is called a repeating decimal. So this is one type of repeating decimal. And when I write it, I only need to write what repeats. Well, 3 is the only thing repeating. So I can write it with 0.3, and then I put this little bar over top. And that little bar is called the vinculum. Don't necessarily need to know that, but it's a cool word to say. So that is the vinculum, or repeating bar. So I would write that as 0.3 repeating, which is different from 3/10. Now, on the back of your paper, we get into this a little bit more. Repeating decimals are decimals that repeat the same part over and over. And we write a line over just the repeating part. Terminating decimals are decimals that end when you divide it. You get that 0. So this one right here, 4/9, ends up working out just like my 1/3 did, where I just keep having the same step over and over. So I just write that as 4/10 repeating. Now some other repeating decimals, you notice in this one right here, it starts out with a 1 and a 2, and then it goes 5, 3, 5, 3, 5, 3. Well, the 1 and the 2 don't repeat, so I don't put the vinculum, the bar, over top of the 1 and the 2. I just put it over the 5 and the 3. I only want to put it over the part that repeats. This instance right here, it's 1.752752. Well, the 1 doesn't repeat, that whole 1, but the 752 pattern does. So I cut it off at just one of the repeating patterns, and I put the vinculum over top. This one would be 22 1/3, because we know we've done this long division where we kept getting that. And you can see that it's written as 22 with a funiculum, a repeating bar, over the 3. So let's take a look at some of these fractions down here and see if we can figure out if they are repeating or not. So this first one, 2/3, I'm going to put the 2 inside and the 3 outside. Right away, I'm like, nope, can't do that. Can 3 go into 20? It can 6 times. So 6 times 3 is 18. I subtract. I'm like, oh, look. 20, 20. It's going to keep going on. Doesn't matter how many times I do it. So I'm like, up. That is a repeating decimal, and that's what repeats. So it's 6/10 repeating. Our next one's going to be 11 divided by 16. And 16 can't go into 1, 16 can't go into 11, but it can go into 110. And if you count up, you get 16, 32, 48, 64, 80, 96, 110. So how many did we go up there? So let's take a look at that. 16, 32, 48, 64, 80, 96, 110. Oh, no, sorry, 100, that would be 112, wouldn't it? That's what threw me off. So 1, 2, 3, 4, 5, 6 times gets me to 96. And when I subtract, I'm going to have to borrow. And I get 14 left over. Sorry about that. Thought I hit pause while I was whiting that out to give myself room. So now we got to go 16 into 140. So I might want to extend this up here and another 6 added onto that. Alrighty, so once we found that 16 times 6 was 96 and we did that subtraction, when we brought that down we had 140. So if I continue to count up here, let me fix that right there. If we continue to count right there, we find that to get into 140, the closest I can get is the 8th time, which is 128. And when I do that subtraction, I end up with 120. And so now I've got my list of 16s up here, which is helpful. So I can go 1, 2, 3, 4, 5, 6, 7. I'm like, okay, I can go in 7 times. 7 times 16 is 112. I subtract, I get 8. Add a 0, bring it down. Oh, look, that one's in my list. 1, 2, 3, 4, 5. So I got to a 0. It was a longer one, but this is a terminating decimal because I end up with a 0 if I keep doing the division. This next one right here, 12 out of 24, I want you to really get good at recognizing that 12 out of 24 is half. So half as a decimal, we want to just know is 0.5. We want to just be able to look at that and do that. I can do 24 into 12 and add the 0 and go, oh, guess what? It's 5 times. But that is one we should really just know. This last one right here, 1/9. That's going to go in there 1 time. And look, I'm going to keep going. So that's going to be repeating decimal. And it's just the 0.1 repeating. Feel free to go back and watch this as many times as you need to and ask me questions if you have them. Pause them, try out the problems. I hope this was helpful.